Good day, students. Welcome to mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the Algebra 1 Common Core New York Regents exam for June 2016. All right, let's take a look at question 11. It says, the range of the function f of x equals x squared plus 2x minus 8 is all real numbers. And then which of the following statements is correct? So one reminder concerning range, we have range and domain. So the difference is range has to do with the vertical span of the graph. How high does the graph go? How low does it go? Or you can think about the projection of the graph onto the y-axis. So you're looking at the set of acceptable feasible outputs for a function, okay? On the flip side, the domain is the inputs, the horizontal span of the graph or the projection of the graph on the x-axis. Okay, so in this case, we have a parabolic function because the highest degree is 2. So we are either going to have a parabola that opens up or a parabola that opens down. Okay. In the case of it opening up, the range is going to be the lowest to infinity. And if it opens down, we're going to have the maximum down to negative infinity. Okay. So the question is, what is the opening of this parabolic function that we have right here? I'll show you two methods of finding the range. One of them is manual, the other involves using the calculator. So we have f of x equals x squared plus 2x minus 8. So let's do it without the calculator first, okay? With this setup, a is 1, the coefficient of x squared, b is 2, and c is negative 8. Now, since a is 1 is greater than 0 or positive, that implies that the parabola does what? The parabola opens up, okay? So if the parabola opens up, it's going to have a minimum point and everything above. So in this case, the range is going to be the set of all y's from the minimum f min all the way to infinity. Okay, what does this look like? So if we have, let's say we have an upward opening parabola like this, upward opening parabola, because a is positive, this is the lowest point known as f min, okay? F min, that's the y coordinate, and then of course it has an x component. So the range is the vertical span of this graph from the lowest point all the way to the highest point, okay? So we project it onto the y-axis. What we are going to have is a line that looks like this. It starts from the minimum and goes up forever, okay? So the y coordinate of the minimum, we're going to call it f min. And the highest point is infinity because this line indicates that the graph goes up forever. All right, so our range is basically a set of all points from f min to infinity, or you can write it as the lowest point, which is basically our f min, and every y value that's bigger than it. Okay, so y is greater than or equal to f min. That's what our range is. This is interval notation. This is inequality notation. So let's go ahead and find out what our f min is, and then we'll plug it into this formulas to determine what our range is, okay? All right, let's go ahead and consider the formula for finding the minimum. So the formula is, so f min, in this case, it could be f max too, but this one opens up, so it's f min. F min is f of negative b over 2a. Okay, this is also the y coordinate of the vertex. So in order to find the f minimum, which will be our lowest point for the function, we just need a and b. As indicated earlier, a is 1, the coefficient of x squared, and b is 2, the coefficient of x. So first of all, we're going to find the x coordinate of the vertex, which is also known as negative b over 2a. That is what we're going to be inputting into the function to find the minimum value. So you're going to have negative b over 2a. When you work this out, you end up with negative 1. Okay. Now, the f-min, which is f of negative b over 2a, is f of negative 1. So that simply means we're going to plug in negative 1 into the original function. Let me write down what the original function is here. The original function, f of x, is x squared plus 2x minus 8. Okay, so f of negative 1 is going to be negative 1 squared plus 2 times negative 1 minus 8. Now we use our order of operations to simplify this. We have negative 1 squared is 1, plus 2 minus times negative 1 is negative 2 minus 8. So 1 minus 2 is negative 1, negative 1 minus 9, minus 8, sorry, is negative 9. Okay, so that is our f minimum. So f min is negative 9. Now, what is our range going to be? Let's go ahead and write that down. Our range in two formats is from negative 9 all the way to infinity using the interval notation, or a set of y's that are greater than or equal to negative 9. Okay, in word form, the range is the set of all real numbers are greater than or equal to negative 9. Okay, so there you have it. Okay, let me show you how to do this with your calculator. So what you do is you go to the y window, and then you type in the function x raised to the second power plus 2x minus 8. Enter, and let's graph the function. So there goes the function right there. You see it's an upward opening parabola, which shows you that the function has a lowest point, namely the minimum, and it goes up forever. So what are the coordinates of the vertex? What's the coordinate of the vertex right there? So we need to use calculate. Second function trace will take us to the calculate. We're looking for minimum in this case. So I will left bound, put your cursor to the left of the minimum, right bound, put your cursor to the right of the minimum. Enter, enter. Your minimum is negative 1, negative 9. So that's exactly what we got, okay? So you see that the y coordinate is what we're looking at, because recall your minimum point, your range is in the y direction. Okay, so now what I just did is I just took a snapshot of the calculator's results. So let me show you visually how to read off the domain from here. Okay, so this is the lowest point. This is the lowest point right here, is equivalent to negative 9 on the y-axis. So from the lowest point all the way up, from there all the way up, that's what your range is. Okay, let's use red so you can see what's going on here. So from the lowest point and everything above, that's your range, okay? Because the range is the projection of the graph onto the y-axis. If you project that onto the y-axis, you have the set of numbers from negative 9 all the way up, and that would be your domain, your range, which is y greater than or equal to negative 9, basically the set of all y's, something like that. All right, so that's how you do it with your calculator. Okay, let's take a look at problem 12. It says the zeros of the function f of x equals x squared minus 5x minus 6r. So let's take a look at the formula for finding the zeros of a function. So to find zeros, all you simply do is you solve f of x, set the function equal to 0, solve that for x. And that will give you, that's basically how you find the zeros for a function. Okay, So in this problem, problem number 12, the function under consideration is x squared minus 5x minus 6. So to find the zeros, we take the function and we set it equal to 0. How do you solve this resulting quadratic equation? We can use any factorization technique we like. We can use the box method, you can use the asterisk method, you can guess and check. I like to use the AC method. So AC goes on top, B goes on the bottom, also known as the X gain. We have -6 and -5. So we ask ourselves, what two numbers multiply to give you -6 and add to give you -5? So you gotta be careful here. Why do I want you to be careful? This is a problem where there are two pairs that might work, but when you really focus and pay attention on the signs, pay attention to the signs, then you know which one is actually accurate, okay? Now let's look at the product of numbers that yield 6 and add or subtract to give you 5. 1 and 6 multiply to give you 6. The difference is 5, right? 2 times 3 multiply to give you 6, but you can also combine them to give you 5. So that is what makes this a very tricky problem. So how do you know which one is correct? You want to pay close attention to the signs, okay? Make sure that the pair you select actually multiply to -6 and add to -5. So let's try 1 and 6. Since the sum is negative, the bigger has to be negative. Now when you multiply 1 and -6, do you get -6? Yes. When you add, combine 1 and -6, 1 minus 6, you get -5. The answer is yes. So these two work, okay? So that gives us a factored state, x plus 1. That's this x right here. And then x minus 6, the second factor right there. So that equals to 0. Now we're going to use a zero product property, set each factor to 0. And isolate your x, and that will yield your zeros. In the first equation, subtract 1 from both sides, and that gives us x equals -1. On the second equation, you add 6 to both sides. That gives you x equals +6. So our zeros are, what are they? -1 and 6. Answer to number 12 is option number 1. Okay, let's take a look at number 13. It says, in a sequence, the first term is 4, and the common difference is 3. The fifth term of the sequence is, so when you're talking about common difference, we're talking about repeated addition. Okay, so I have that side point listed here. So common difference means repeated addition, and it helps you generate terms of an arithmetic sequence. Okay, when you have common ratio is multiply, common difference is add, ratio is your geometric sequence, and common difference is your arithmetic sequence. Okay, so let's keep that in mind. All right, so let's write out the formula that can be used to generate the terms of an arithmetic sequence given the first term and common difference. Okay, so formula. So the nth term is basically given by an equals the term before it, an minus 1, plus the common difference. Okay, so let's apply that to this scenario. So we have the first term, a1 is 4, and the common difference, d, is 3. We can use this to generate subsequent terms. So a2 is the second term. a2 is going to be the term before it, which is a1 plus the common difference, which is 3. Follow this formula here. a1 is 4, 4 plus 3 is 7. Okay, how far are we going? The index tells us how far to go. We're going to the fifth term, okay? So the third term is going to be the term before it, the second term, plus the common difference of 3. The second term, as determined in our previous calculation, is 7. 7 plus 3 is 10. The next term, the fourth term, is the term before it, a3 plus the common difference of 3. The third term is 10. Add 3 to that, you get 13. So do you see the pattern here? We are adding 3 over and over and over again, right? That's what an arithmetic sequence is, where every term differs from the previous by a constant number or value known as your common difference. Okay, so A4 is 13. Add 3 to that, you get your fifth term, which is 16. Okay, so this is our first term, second, third, fourth. We're asked to find the fifth term, which is this one right here. Okay, so our answer is option number 3. All right, let's take a look at number 14. It says the growth of a certain organism can be modeled by this function right here, this exponential function, where C of t is the total number of cells after t hours. Which function is approximately equivalent to this right here? Okay, so what we're going to be doing is we're going to be applying our property of exponent. The particular formula we're going to be using here is as follows. If we have a raised to a product of two numbers as the power, axy, that can be written as a times x times y, and that can be written as a to the x quantity raised to the y. Okay, this is known as the power of a power property of exponents, going backwards in this case. Okay, so we have the function c of t equals 10 times the exponential term 1.029 raised to the 24t. Now we can express this power as a product of two values, so it's 10 times 1.029 raised to the 24 times t. Now we apply this rule that we talked about up here. We can rewrite this as 10 times 1.029 raised to the 24th power. See that 24, we can bring it in. Basically separating the powers raised to the t power. You see that? Now we can plug 1.029 into our calculators, and we can get the approximate expression that's equivalent to c of t. All right, so let's go ahead and enter that. We have 1.029 raised to the 24th power, and is 1.9859 to 3 decimal places. That's what we have here. So we have 1.986 raised to the t power. That's what c of t is equivalent to approximately. Answer is option number 3. All right, let's take a look at problem 15. It says a public opinion poll was taken to explore the relationship between age and support for a candidate in an election. The results of the poll are summarized in the table below. What percent of the 21 to 40 age group was for the candidate? Okay, so we have it broken down by ages, for, against, and opinion based on the rows that are given here. So we're looking for the percentage of 21 to 40 that are for. Okay, so we are focusing our attention on this row right here. Which one is 4? So we're looking at the 4. What percentage of this whole row is 4? All right, so let's take a look at the formula that will guide our problem solving process for this problem. So this is a setup right here. Percent over 100 is equal to part over whole. Okay, so that's the formula we're going to use. Now, what is the percent that's for the candidate? Percent for the candidate is what we're looking for, so that's our unknown. All right, what's the part? How many are for in between the ages of 21 to 24? We have 30, okay? So that's a part. And then what's the whole? What's the total number of people in that age bracket on that we surveyed? So to get the whole, what you do is you compute the sum of these three values, for, against, and no opinion. So 30 plus 12 plus 8. When you sum it up, you get 50. Okay. We have everything that we need, so let's go ahead and calculate the percent. So we're going to do percent over 100 equals the part, which is 30, over a whole, which is 50. To get percent isolated, we multiply both sides by 100. 100. This divides out. Now let's see what happens here. The zeros and the zero cancels out. So let's see. That gives us, let's put it down a little bit. The percentage for is 30 over 5 times 10. No, yeah. And then let's see, 5 goes into 30, right? 5 goes here 1, 5 goes into 36 times. 6 times 10 is 60%. So 60% of the people within the ages of 21 to 40 voted for the candidate. Answer is option number 4. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam or just a review of the test, do give us a thumbs up. Your positive feedback is very valuable to us. Any questions or comments, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe for updates to the rest of this review series. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.